Ladies and gentlemen, please welcome President, Server and Tools Business, Satya Nadella.
Good morning and welcome to TechEd 2012. First of all, thank you so much for being here. I know it takes a lot to travel over the weekend and spend an entire week with us. So on behalf of all of us at Microsoft, we deeply appreciate your commitment and everything you do, and hopefully this will be a great conference for you. This is a pretty special event, so I wanted to also have some special welcomes for all the first-time TechEd attendees out there. And one special group that we have here is the winners, the US finalists of the Imagine Cup tournament, which is the students tournament that we have from Arizona State University. They have a very, very cool app that they've built. It's a web app with a mobile front end, which really deals with an issue that I think all of us care a lot about, which is about how do we get food, perishable food in particular, to the shelters and the homeless. And so it's a fantastic app, and they're going to go to Australia for the global finals, so good luck to the team from Arizona State. This is also a very special event. It happens to be the 20th anniversary, the 20th TechEd. I had the good fortune of being here in 1993 for the very first TechEd in Orlando. I remember it was 1 year into my Microsoft career, and I remember coming in one night, and I was immediately recruited, I think, to stuff the conference bag all night. And also, if I remember right, it was sort of probably the first and last time I had to room with people I didn't know in a hotel room. Because we just completely blew all the forecasts. We had more people show up than we thought. We had lots of sessions added. It was an amazing time and an amazing conference. And here we are 20 years later in 2012, and that excitement continues into a new era. The 1993, if you look back, it was really the dawn of the client-server era. Pentium had been just announced, so 32-bit operating systems and 32-bit chip architectures were becoming mainstream because Windows NT was also beginning in that same time frame. So it was possible to start imagining that you could have Intel-based servers run the back ends of many of the compute jobs that traditionally ran in minis or mainframes. And then, of course, having a 32-bit operating system with Windows NT, that started becoming a lot more real. The tools innovation, especially with Visual Basic coming on live, it was possible for many of us to start building these new applications and really getting the first generation of client servers started. And subsequently, obviously, we had that revolution over the last 20 years play out in a very major way. We are at the beginning of another inflection point, a major shift. And whenever we talk about shifts, I think it's best to conceptualize them in terms of application architectures, because applications then drive the infrastructure and the entire cycle around them. The new era is something that we've been referencing and calling the world of connected devices and continuous services. This is a very distinct phase. It's different from client-server in a variety of ways, and we'll talk a lot about that. But the key question is, how much of a departure is it from what we've been doing? And I think it is very important for us to approach this as a huge opportunity to reinvent ourselves. Clearly, there are things that we do today that are going to change, some of them fairly dramatically. But the opportunity that we have collectively as a community is to reinvent ourselves to drive even more value. Because if you look at sort of history of computing, with each of these generational changes, only one thing has been secular and true. That is, in each one of these generational shifts has created more agility, more innovation, and more value to the business. And that's going to be absolutely true with this next shift. We will have to question that nexus that exists between end users, application developers, and IT, and how we work that loop of virtuousness, but at the same time, none of us should be confused that the opportunity to add value will only amplify. So that's really what this entire conference is about. That's what this talk is all about. And for us, in server and tools in particular, the folks responsible for the back-end computing infrastructure inside of Microsoft, it really manifests as a new operating system. Just as in 1993, we were talking about a full 32-bit operating system with Windows NT, we now get to talk about a new operating system and the beginning of a new era. And anytime you talk about operating system, two things really pop out. The first thing is the new hardware abstraction. In other words, every time you talk about an operating system, its major job is resource management, and resource management at the scale of the hardware. And as that shifts, you need to sort of reconceptualize the basic meaning of an operating system. The new hardware abstraction that we are dealing with is at a data center or a multiple data center level. So you're really thinking about compute, storage, network as a unit, and at data center scale and multi-data center scale, and really thinking about resource management with all of that in mind. So that's really the modern data center for us. The next element is the application platform. To run these continuous services, both stateful and stateless, you need to be able to reconceptualize the runtime, the frameworks, and the tools, and the life cycle around the tools so that you can run these services 7/24. So that really is the gist of what we're going to discuss over the next 90 minutes. The modern data center, the modern application framework that make up the cloud operating system, the basic underpinning for this new era of connected devices and continuous services. When you talk about the modern data center, it's perhaps best to start with what's happening at the system level, what's happening at the silicon, what's happening to a single blade, a single system, and then a cluster. The fundamental thing that all of us at this point are tracking pretty closely is the notion that storage, compute, and network are co-evolving. I mean, if you think about the compute power, for sure the Moore's law is still continuing to work in its full glory. It probably is resulting in more core density versus perhaps the single thread performance. But still, we are able to pack amazing amounts of compute power. Once you have a lot of compute power, there is not much use to it if you can't really have the IOPS that have to go with it. And so the revolution in storage, especially around tiering, is what's really in full play. Because the disk speed itself is not something that's going faster, but at the same time, the fact that SSD costs and flash costs are coming down give us a huge opportunity to rethink, especially if you think about what's happening in the database world with in-memory. You can sort of see that you can start thinking about applications and application performance and IOPS per dollar in a very different way in terms of the nexus between CPU utilization and storage access. But you know, one of the things which is really an artifact of the CPU to storage connection is the network. It's the fast interconnects. It's sort of the era of the fast interconnects between storage and compute that's driving a lot of innovation. And the key to this co-evolution of storage, compute, and network is really software control. You really cannot afford to have the control fragmentation, because if you do that, then you're not going to be able to achieve the economic benefits, the agility benefits, and the innovation benefits that these new systems at high density can provide. Now, perhaps you can sort of say, well, that's something that's been true. After all, Moore's law has really played this out even in the past, over the last 10 years in particular, as we have gone to these clusters and blades and cluster-based solutions. But one of the fundamental things that I believe that has changed is services at scale. And this is a very big difference for me personally since 1993. When we were building Windows NT, we didn't have in-house at-scale workloads on NT. Subsequently, we got onto a fantastic virtuous cycle, which is the fact that we had hit workloads in Exchange and Link and SharePoint and SQL Server ensured that with each release of our server operating system, we were able to get the feedback from you and learn continuously from you and make that product better and better and better and more robust. And that's sort of testament to sort of all the deployments that we have. But for the first time now, the same kind of cycle of learning is playing out when we talk about internet scale services. Just think about the depth and breadth of the first-party workloads that Microsoft is running today on a daily basis. We have Xbox Live that's doing some fascinating GPU simulation in the cloud for some of their games. You have Office 365, which is Exchange and SharePoint at scale. You have Dynamics CRM, which is a stateful transactional application in the cloud. You have Bing, which is really a big data applied machine learning application in the cloud. You have things like Health Vault, which is secure transactional consumer applications. So you have a very broad spectrum. So we run approximately 200 very diverse workloads across Microsoft. That diversity is what's really making us build the right operating systems, the right management stack, right tools. In fact, perhaps the best way to illustrate is what happens to us on a daily basis. For example, just in terms of the physical plant, we have around 16 major data centers across the globe. We have around 1,000 access points. We have a couple of hundred megawatts of power, powering hundreds of thousands of machines. We have terabits of network out of our data centers. We have petabytes of data. In fact, Bing itself has got approximately 300 petabytes of data. We write something like 1 terabyte of record each day. Now, all of that, you could say, is fascinating statistics. What does that really have to do anything with infrastructure that we build? It's just that we are battle testing every piece of software. Just in fact, last week, we upgraded all of the Bing front ends to Windows Server 2012 RC. And so today, Bing is running the release candidate of the next server operating system in full production workload. That type of feedback, where we are constantly able to take the learning internally, is what's shaping the host OS, the guest OS, the frameworks, the tools, the performance, and that, we believe, is not something you can't just head fake it. You can't just go in and say, we've built it for scale without having run it yourself. And I think that that's perhaps, in the long run, going to make one of the biggest distinctions. Of course, none of this matters if we can't scale minimize it, because it's not as if every deployment of a private cloud or a virtualization instance is going to be at the scale we run. So the key is for us to be able to take all of that power, all of that learning, package it up into the smallest of clusters, half a rack, a full rack, or what have you. And that's really what our intent is. And when you think about that as the backdrop, the criteria to look at a modern data center, there are 4 key attributes that I would say that one should look at. The first one is the scalability and the elasticity. And you need the elasticity to go with it, especially in the context of a heterogeneous set of workloads when you're running in particular highly virtualized distributed environments, because you want to get utilization up. And without elasticity, you're not going to be able to achieve it with all the amount of scale. The second one is always up, always on. There's no point having all of the scale and elasticity without the continuous availability. Shared resources, building out for multi-tenancy from the ground up. It could be when you're private cloud, the fact that you're running 2 departments, 2 applications, and you want to be able to isolate them. And then, of course, automating, because you can't linearly scale your operations with your infrastructure, and that means automation, automation, automation. And that is something that is a very super important thing to make sure that the system provides the hooks for you to be able to achieve that and then lower your costs. So that's what really inspired us to build Windows Server 2012. It's an amazing, amazing release. In fact, as we were preparing for this event, perhaps the biggest struggle we had is we have a 90-minute keynote. We have a lot to show. What features of Server 2012 do we even get to demo and talk about is perhaps the thing that really troubled us the most. But Windows Server 2012 has hundreds of features, and I just wanted to highlight a few of them in the context of this notion of a modern data center. When it comes to scalability and elasticity, the performance gains, the sheer capability gains of the host operating system, Hyper-V 3.0, are just stunning. Just one of them, the notion that we now have on one VM, the ability to support 64 virtual procs and 1 terabyte of memory, is something stunning, because we can now run pretty much 99% of the tier 1 SQL workloads can be virtualized on Hyper-V 3.0, and it's a pretty stunning figure, and you'll see a lot more of that. Always up, always on is something that, again, has been built deeply into the system. Something which is sort of a feature that I love the most is this ability to update the cluster without having to bring down the cluster nodes and have continuous availability. Continuous availability of storage, huge gains in that dimension. Shared resources, again, multi-tenancy, both with System Center and Windows Server, has been built into the foundation. The ability to have network virtualization, storage virtualization to go with server virtualization is what makes it possible for you to have a fully virtualized environment that is shareable. And if you have these multiple workloads from multiple departments, you can isolate them using policies. You can monitor the resource usage using policies and make sure that there isn't one workload that takes away all of the resources. So a lot of gains, again, when it comes to sharing of resources across the virtualized infrastructure. And lastly, when it comes to automation and self-service, we have done a lot in terms of exposing the surface area of PowerShell. It's actually a pretty amazing release for those of you who are big PowerShell users in terms of the commandlet explosion that we've had, so that you can automate pretty much anything that's there in Windows Server. We have 2,400 commandlets in PowerShell. We have built-in standards-based management, and of course, with System Center, you have a full capable data center management suite. So to show you some of this in action, I wanted to invite up on stage Jeff Woolsey from our Windows Server 2012 team. Jeff?
Thanks, Satya. It's a pleasure to be here. How's everybody doing? Oh, come on, how's everybody doing? Awesome. Welcome to Orlando. This is a big, big, exciting show. Well, Windows Server 2012 is about making your business more agile. It's about making your data center more flexible and providing you the ability to extend your data center to the cloud securely on your terms. Quite simply, Windows Server 2012 is about providing the best cloud OS. Let's start with scale. With Server 2012, we want to virtualize those workloads considered non-virtualizable. Workloads that require dozens of cores, hundreds of gigabytes of memory, are likely SAN attached and with exceptionally high I/O requirements. Well, today, we want to redefine performance. We want to redefine scale. So today, with Server 2012 and Hyper-V, we'll support up to 320 logical processors per server, up to 4 terabytes of memory per server, and up to 64 virtual processors per VM. In addition, you can see I've got 100 gigabytes of memory allocated to this virtual machine, but we'll support up to a full terabyte of memory per VM. And whether this VM has been allocated 10 gigabytes, 100 gigabytes, or a full terabyte, it still costs the same. In terms of virtual storage, our virtual disks now support up to 64 terabytes per virtual disk. That's 32 times anyone else in the industry. We also support the largest clusters with 64 nodes and up to 4,000 virtual machines in a single cluster. Now, if I give you a virtual machine with 64 virtual processors and a terabyte of memory, quite honestly, that's irrelevant if I can't provide the ability to give you the I/O to actually keep those workload and those resources busy. So let's take a look at Hyper-V I/O performance. Now, before I do, let me tell you a little bit about the hardware I'm about to show you. This is an industry standard 4-socket server. It's got 80 logical processors, 256 gigabytes of memory. It has 5 LSI HBAs attached to 40 SSDs. Now, you may be thinking, hold on here, why is he using SSDs? Why is he not using traditional spinning media? Well, for this next demo, we certainly could have used 15K SAS disks. However, we would have needed 4,000 disks in 10 full-size 42U containers, racks, full of disks. So we decided to opt for SSDs instead. Let me show you. I'm going to switch on over here to Iometer. Iometer, an industry standard tool, and in fact, the configuration and test that I'm going to run, industry standard. This is 4K random IOPS. This is the hard stuff, not the easy sequential stuff. This is 4K random IOPS. Queue depth of 32, 40 concurrent threads. By the way, the guys over at VMware claim that they can deliver up to 300,000 IOPS from a single VM. Well, let me show you, with Windows Server 2012, we're delivering 985,000 IOPS from a single virtual machine. Let me say that one more time. Over 3 times more IOPS from a single virtual machine. And let me be very clear. This is not a Hyper-V limitation. We can go much, much higher. This is as fast as the hardware will go. We couldn't put any more host bus adapters in this machine. So, with support for up to 64 virtual processors, a terabyte of memory, and nearly 1 million IOPS in a single server, we can run over 99% of the world's SQL Server. Now, while we're talking about storage, by the way, let me talk about some of our other investments in storage. For example, in Windows Server 2012, we've made some huge investments in file-based storage. For example, we have a new scale-out file server. With the scale-out file server, it intrinsically, because of the architecture, it's an active-active architecture, which intrinsically, inherently means as I add more nodes, I get more scale, but I also get more continuous availability because I can remove or add nodes without any downtime. It's an extremely powerful new capability in Server 2012. And then there's what we've done with SANs. Quite honestly, this is earth-shattering with offloaded data transfer, or ODX. With offloaded data transfer, Windows Server 2012 can leverage the native SAN array capabilities in your array. Let me show you. In this first example, I'm going to copy a 10 terabyte file from using non-ODX storage. Now you can see in this example, from CPU standpoint, I'm getting about somewhere between 35 to 40% CPU utilization. In terms of networking, you can see we are fully saturating Ethernet. We're getting about 78 megabytes per second. Not too bad, but in this case, the server is performing all of the copying. It's reading from the source and writing to the destination, reading from the source and writing to the destination. Well now, on split screen, let me actually copy the same file, 10 gigabyte file, using ODX-enabled storage. Now, make sure you don't look away. I'd hate it if you missed the demo here. Again, this is a 10 gigabyte file, and what are you seeing? You're seeing that I'm copying and getting over 1 gigabyte per second. I'm copying a 10 gigabyte file in 10 seconds. This is awesome ODX-enabled storage from our partners over at EMC. And by the way, there was no network utilization at all because this was leveraging the capabilities in the array. When you couple ODX with a bunch of our other enhancements in storage, virtual fiber channel, cluster enhancements for replication and synchronous replication, as well as a swath of other capabilities, quite simply, if you own a SAN, Windows Server 2012 is a no-brainer. It's really that easy. Now let's talk about networking. In Server 2012, we made a huge investment in networking. For example, network virtualization. With network virtualization, I can have multiple companies, disparate organizations, all sharing the same physical fabric with secure multi-tenancy. In addition, we have features like Windows NIC teaming that brings LBFO into the box, and literally dozens and hundreds of new capabilities when it comes to Windows Server networking. In terms of the Hyper-V switch, we've done a tremendous amount of work in the Hyper-V switch for performance, security, manageability, automation. And one of the things we did was we knew that we couldn't be all things to all people. So what we decided to do was also make it open and extensible. So for example, I'm going to go here to the virtual switch manager, and you can see I've got the Cisco Nexus 1000V for Hyper-V running right here. Now, in this case, you can see in the split screen, I've got a couple VMs over here that are using quite a bit of bandwidth, and my network admins, they like to keep an eye on their network utilization, and they want to apply a QoS port policy to this. No problem. I can manage it because I'm using the Cisco Nexus 1000V in the same way I manage my other infrastructure. And in this case, I'm going to use simply the Nexus 1000V admin tool, and I'm going to modify the port profile, and I'm going to use a QoS port profile. And like that, I'm applying QoS port profiles on my virtual switches just like I can on my physical switches. Now, this is just one example of the ecosystem we're creating with the Hyper-V extensible switch. While you're here, make sure you check out the Tech Expo. We've got a lot of partners that are plugging into the extensible switch, and in fact, there's a lot of excitement in the industry around where networking is going right now, and including a lot of people embracing software-defined networking. Now let's talk about automation. One of the best ways to reduce cost and improve efficiency at scale is pervasive automation. With Windows Server 2012, we're dropping in a V12 world-class automation engine in PowerShell. With over 2,400 PowerShell commandlets, everything you want to do in Server now can be automated. And got a winner out there. One of the things we wanted to do is in this next demonstration, I wanted to show how we're coupling PowerShell with site migration capabilities utilizing one of our hotly anticipated features, Hyper-V Replica. So in this case, I'm going to bring up System Center, and I'm going to start my runbook. Now, what I've been doing is I've been using Hyper-V Replica to replicate virtual machines from one site to another. Now what I want to do is I actually want, in a systematic and methodical way, to actually bring them up on my new site. So first, I'm going to type in my destination host. Going to type in my source host. And I'm going to provide the server that's actually going to do the runbook automation, and I'm going to click Start. Now, while that's happening, let's move on over to instances and view the details. And you can get a high-level overview of what's actually happening here. What's happening here through runbook automation is System Center is using PowerShell as the automation engine to actually make sure that everything is in place to begin the migration from my workloads from one site to the next. It will then bring up my virtual machines in the correct order with dependencies configured in the runbook automation. All of this very cool, brought to you by Hyper-V Replication, and of course, at its core, PowerShell. Now, what if you don't want to just migrate your workloads, but what you'd really like to do is extend your data center to the cloud using capabilities and capacity from a provider? Well, let me show you how we do that with Windows Server 2012 and System Center 2012 SP1. You can see here I've got a view of my clouds on-premise. Dev cloud, infrastructure, pre-production, and production environments. But what I'd like to do is I'd like to connect to my service provider. So I'm going to go to Connections, which is where I broker connections. Here I'm going to click on Connect, and you can see I have the option to connect to another VMM server or use SPF, the System Center Provider Foundation. This is a powerful new capability that allows me to take on capacity provided to me by my service provider. Now, in this case, I bought capacity from Orlando Hosting, and they have provided me a URL. Of course, I need a certificate for pretty obvious reasons, encryption. Type in my password and click OK. And what you're seeing is in a few easy steps, what I'm doing right now is System Center is brokering the connection with Orlando Hosting so that I can provide that capacity and manage that capacity under my control. In fact, if I go back on over here to Clouds, what do you see? You'll see that Orlando Hosting now appears in my console in the context of my other clouds running on-premise. Very cool stuff here, folks. So in just a few moments, we've flown through literally a whole bunch of technologies and capabilities, but one thing I want to be very clear about, quite honestly, I haven't even scratched the surface of what's new in Server 2012. With massive scale, massive performance, complete VM mobility, the only virtualization platform that allows you to live migrate servers with nothing but an Ethernet cable, PowerShell automation, offloaded data transfer, and the ability to extend your data center to the cloud with System Center. Quite simply, these are just a few of the dozens of reasons why Windows Server 2012 and System Center 2012 is the best way to cloud optimize your business. Thank you very much.
So hopefully you got a quick glimpse of the power in Server 2012. It's a fantastic release, and I think over the course of this conference, you will get a chance for many drill-down sessions on the hundreds of features in Server 2012. Ever since the beta, we've had some tremendous traction with our customers. Over 300,000 customers used the product since beta, in fact, the first 3 months after the beta. Since we went and had the RC launch, in the first week, we had 80,000 customers download the RC. As I said, internally, we have RC deployed in production. We had 150 customers who were part of our TAP program that we worked very closely, many of them already taking the RC and putting production workloads that we support. So tremendous amount of progress. So let's roll a video with some of the comments from the customers who've been using Windows Server 2012.
What I saw today absolutely took my breath away. This is game-changing.
Everything has been looked at. We're seeing features that aren't just good, they're great.
I have a number of jaw-dropping moments for me today.
This takes private cloud from the competition and puts Microsoft in the driver's seat.
For a software company to tackle the networking layer and tackle storage and rethink the way you do that, yeah, that's brilliant.
And you can move virtual machines from one to the other, no downtime. That's what customers want. No IP changes, one cable, that's all you need.
I wouldn't even look at VMware now.
Continuous availability, disaster recovery, Hyper-V, everything that is going to allow us to build our private cloud and offer software as a service to our customers.
Things that before we would have to license it and were typically fairly expensive are now in the box. It's done. It's there.
And as Jeff was mentioning, we are building Windows Server 2012, of course, to power your data centers and your private clouds. But we're also building it with in mind an overall broader ecosystem. We want to make sure that there is a consistent world of Windows Server across the service provider, Windows Azure, as well as your data center. And that's one of the most important technical and strategic goals for us at Microsoft. When we say consistency, the key thing is for us to ensure that identity, virtualization, management, and development is something that is consistent across the service provider Windows Cloud, your data center, and Windows Azure. And in that context, last week we announced a major set of revamp and features for Windows Azure. And one of them was our infrastructure as a service. With the launch of infrastructure as a service capabilities in Windows Azure, you now have virtual machine portability with no changes to format, the ability to take an app and a workload and move it transparently from your own private cloud to Azure, to a service provider, and back with no lock-in is something that you can do. So I wanted to give you a feel for some of the new capabilities in Windows Azure and the infrastructure as a service. And to do that, I wanted to introduce up on stage Mark Rusanovich from our Windows Azure team. Mark?
Good morning, everybody. So I know most of you like automation, especially with PowerShell, but we wanted to make it so easy to create virtual machines in Windows Azure that even your boss can do it. And so for that, I'm going to switch over to the newly designed and Metro-optimized Windows Azure portal. Now, there's been an explosion of a certain class of devices and a specific device that I suspect many of you are using. So we wanted to make sure that this new portal works on all operating systems and all browsers. So to answer your question that I know you've got in your head, yes, it'll look great on your Nokia Lumia 900 Windows Phone 7 device. Now here you can see all the resources that we can manage in the portal, including virtual machines. We've got a consistent experience for creating new resources here you can get with this new button down here. I'm going to show you how to create a new virtual machine and how easy it is. when I select this menu item, I've got two options. One is Quick Create, which lets me, with a single dialog box, pick the most common options for creating a virtual machine in one click. But I'm going to show you some of the more advanced features that we've got with this release by picking the Gallery option. And so you can see the list of platform images I can select from, and no, we haven't been hacked. We've actually got Linux up here in Windows Azure. We've worked closely with these companies making these distributions to support them on Windows Azure. But for this demonstration, of course, I'm going to pick the best operating system in the list, the one that is so good that it doesn't even need an icon, and that is Windows Server 2012. Press Next here. I've given it a sample name, a password that'll make it happy. Hope I got those matched, and press Next. Now, in this dialog, I get asked whether I want to create a standalone virtual machine or to add this virtual machine to an existing virtual machine to create a cloud service that consists of multiple virtual machines. I'm going to go ahead and select standalone virtual machines, give this virtual machine a DNS name that I can access it over the internet with. And now I pick the storage account into which I want the operating system VHD to be placed. And that's because we're using Windows Azure storage underneath to store VM VHDs. I click Use Automatically Generated Storage Account, and it will create one for me, or I could pick one that I've already got. And then I get this drop down here that asks me where I want to place this virtual machine. I can pick from any of the number of data centers that we've got Windows Azure running in across the world, or I can even pick to deploy it into a virtual network, which is a VPN gateway subnet up in Windows Azure that connects back to a CorpNet. And so I'm going to pick the VPN network that I've already got up there, the Corp network, and press Next. And this final dialog lets me pick some of the scale-out and high availability op features that we've got that I'll demonstrate actually in a few minutes. So I'm going to go ahead and skip that slide and just press Next to go create that virtual machine. Now, Satya said one of our goals was to make it easy to migrate virtual machines back and forth. So let's say that you've got an application running on-premise in your Hyper-V private cloud, like this one right here. It's a simple events manager app. It's built on IaaS and SQL Server. And I want to take that application and migrate it up into Windows Azure. Because it's Windows Azure virtual machines are based on Windows Azure storage, I can simply upload them to Windows Azure storage blobs and then create virtual machines from them. But what makes that simpler to migrate virtual machines is System Center 2012 App Controller that Jeff introduced you to. I'm going to go over to the App Controller dialog here. And you can manage private clouds. You can also manage Windows Azure. I've got that application running here on my private cloud. If I go to the virtual machines menu entry, you can see there it is, Events Manager Local. I've previously made a backup of that virtual machine's VMs, or VHDs, and stored it in the library here. And when I right-click on this and select Migrate, I'll be guided through a simple wizard that will let me push that entire VM with its VHDs up into Windows Azure. I pick the cloud that I want to deploy to. In this case, it'll be Windows Azure. Pick the cloud service I want to deploy into. Here I can create a new cloud service, or I can add this VM to an existing one. I'll add it to this one right here. Press OK. Final step, pick some of the options you saw me pick in the portal there with the Create Virtual Machine wizard, like the instance size. I'll pick an extra large. The storage account I want to upload into. So this is navigating through my Windows Azure storage accounts. I'll put it in the migrated VMs container. And the nice thing about App Controller is this virtual machine actually consists of two VHDs, an operating system VHD and a data disk with a SQL server on it. App Controller knows that and will automatically migrate both of those VHDs up when I press the deploy button. But how about the reverse? Let's say that I've got an application running up in Windows Azure and I want to bring it back on premise, maybe for disaster recovery, maybe for backup, maybe I want to just take a look at it. I've got that Events Manager application. I've already migrated it up with App Controller. You can see it here in this virtual machine list. When I click on it, here you can see a virtual machine dashboard we've got. We're actually having the infrastructure collect performance information and surface it up in the portal, including CPU usage, network usage in and out, as well as disk IOs. Here in the URL, you can see the DNS name assigned to that virtual machine. And just to prove it's actually the same app, let's log in. And we'll see the same exact interface we saw because it is the same virtual machine with the same VHDs. You can see down here, there are the 2 disks that we migrated up, sitting in Windows Azure Storage. Because it's Windows Azure Storage, not a separate storage service, it uses the same storage APIs. And that means that off-the-shelf storage utilities for Windows Azure just happen to work against it. I've got an example utility here, Cloud Explorer. And if I go take a look at the VHDs that I've got running, or the migrated VHDs that I copied up into the cloud here, the data disk and the OS disk, I can simply say copy, paste them into a backup folder up in the cloud. Because this is a copy on write copy, it's almost instantaneous. And now I can take those, copy, and then paste them to download them to my local system. And then at that point, I can just use Hyper-V to create a virtual machine with those VHDs and get the application back up and running on premise. So that's a fairly simple application. How about serious enterprise applications, like ones that are built on SharePoint and Active Directory? We also have features that support those, and we've got people that are already building those kinds of applications. So to show you one, I'm going to invite on stage Senior Vice President and Chief Information Officer at Aflac, Mike Boyle. And we can't resist. We've got to take this opportunity to welcome with a big Aflac. So why don't everybody give him a big Aflac? Hey, Mike. Mark. Aflac.
Good morning, TechEd. Just 2 seconds on Aflac. We were founded in 1955, and we're the #1 provider of guaranteed renewable insurance in the United States. In Japan, we're the #1 life insurance company in terms of the number of individual policies that are in force. And globally, we provide service to over 50 million different customers. So let's talk about Windows Azure and Aflac. We've been collaborating with Microsoft product teams in their strategy consulting practice to evaluate Azure for our web services. There's really 3 primary drivers for what we want to do inside of Aflac. Agility is the first one. We want to be able to rapidly deploy computing services faster than we can do it possibly on premise. The second is flexibility, having the ability to add computing power on the fly for peak activity and enrollment periods that we have during the year. And then last of all, performance. We're anticipating that Azure services will give us the ability to provide a consistent user experience to Aflac's user space by virtue of Microsoft Cloud's geographically dispersed data centers. So what we'd really like to do right now is take you through an example of using Aflac.com. So Mark, you want to fire it up?
Sure. So I'm going to switch over here to the Aflac application running up in Windows Azure.
So this is Aflac.com. Any of you can go and utilize it any day. You can go and find out information about Aflac policies. But let's say you wanted to quote, you're a business owner and you want to get some information. So what is happening with this particular application? It's built on SharePoint 2010 and SQL Server 2012, and it's hosted on virtual machines running in Windows Azure today.
So we'll press next here, or enter.
So basically, we'd go over here and we'd select some products that we want to see. So let's select accident, cancer, and dental, I guess. We go over to the next page. Here's where you would fill out your personal information on this. Take it over by clicking next. And now we're going to pick a time that you want to be contacted. It could be right away, but let's say you want to wait until the keynote is finished today. So we're going to choose 10:30. We're going to choose, go ahead and hit next. And what happens at this point in time is this contact information is being fed from the cloud back through a secure VPN into our data center, and it feeds into our Aflac lead system. It's then fed into our call center's auto dialer for the specified time that the person wants to get their call back. And at 10:30, that call goes out to them, and it connects them to one of our contact center associates.
So let's take a look under the hood to see how that application is built. I'm going to switch back to the portal here, and we've got the virtual machines that make up that cloud service. I'm going to sort, well, here, virtual machines. I'm going to sort by name, and now we can see the tiers pretty clearly by the naming convention we've adopted. First, starting with the SharePoint applications themselves in the application tier. Then we've got 2 SQL servers. They're mirrored, and so we've got a SQL witness for failover. Then we've got 4 front ends for scale out. We've got domain controllers, 2 of them up here in the cloud, because SharePoint requires Active Directory. And then finally, we've got a System Center Operations Manager server monitoring the whole thing. Now, the reason that there are at least 2 of every tier is, instances in each tier, is both or either for availability or scale out. And we can see both of those in action with the web front end. When I click on one of them, If I go to the Endpoints tab, we can see that this HTTP endpoint is actually load balanced. And it's, of course, going to be load balanced with the other 3 SharePoint front ends as well. So customer requests coming in can get directed sprayed across those front ends for scale-out capability. We also don't want that application to go down if there's a single failure in the data center. For example, a top-of-rack switch fails. We don't want that application to come crashing down. So we can instruct the infrastructure to spread the application's instances across different, what we call fault domains, or single points of failure in the Azure data center, by putting them in what's called an availability set. You can see I've got several availability sets here for this application. This one is the front-end availability set with the other front-end instances in them, and that means if a switch fails in the data center, that only half of these instances will be affected, the other half will continue to operate and serve customer requests, and the application will remain online. So tell us about some of the other applications you're looking at migrating up to Windows Azure, Mike.
Absolutely, Mark. We're looking at Azure's viability to host the web properties that service our policyholders, employers, and different types of agents and producers that we have around the world. We believe that Microsoft's technology and services have the potential to dramatically improve the user experience and give us competitive advantage in the marketplace. We'd like to thank Microsoft for this partnership. We're thrilled to be one of the first companies that are actually utilizing this particular space.
Well, thanks for working with this, Mike. And if you'd like to learn more about these features, come to my afternoon session on Windows Azure Infrastructure as a Service. And I'll be giving away one of these Aflac ducks here that we're actually going to give a few away right here. So, all right, so I hope to see you this afternoon. Thank you.
Have a good one.
All right, thank you, Mark and Mike. Windows Azure, hopefully you got a good flavor for the capabilities in Windows Azure. It's the most enterprise-grade public cloud service. Last week, we announced a set of features that we have updated as part of our spring wave. We have this fall-spring rhythm with Windows Azure, and we're continuously improving the service. We think that we're really ready for the mainstream of the enterprise, especially with the coming together of IaaS and PaaS. In terms of the feature capabilities, all the things that we talked about for Windows Server in terms of the release criteria, so to speak, apply to Windows Azure. The first thing in terms of scalability and elasticity, that's what it's really been built for. At the core, you can scale the virtual machines, you can scale the Azure websites, you can scale the cloud services that you build. In terms of always up, always on, that's of course the underpinning of Windows Azure design. The availability sets feature that Mark demoed is something that you inherit even for the IaaS infrastructure from within the core underlying storage and network and compute, and the way it's constructed so that it's resilient to hardware failure or network failure. Shared resources, you can make Windows Azure a seamless part of your data center. The network virtualization capabilities is something that makes that possible. And of course, you can automate everything. Everything that's available, Mark showed a lot of the capabilities in the management portal, but everything is exposed through PowerShell and APIs so that you can automate it and make it part of your own management suite. So we think Windows Azure is really ready to take some of those very mission-critical workloads and use them on the public cloud. And hopefully you'll give that a try as we are in the early access program for infrastructure as a service. So now I want to switch gears. So we talked about the modern data center. We talked about both Windows Server 2012, what it powers in other data centers with service providers, as well as what it does in Windows Azure. After all, Windows Azure runs on top of Windows Server 2012. Now, the idea is, what about the apps? How do we talk about the next generation of apps? And perhaps the best way to get a feel for the modern app is to look inside it and try and get a feel for what is it that is going into all of the application development that many of you are involved in. One of the first attributes is this notion of being very personal. It's tied to your core identity, so something like Active Directory and the core identity becomes very critical in the application development, because you want that identity and the notion of the personalized experience being pervasive through all of the various devices you use or access that particular application. So personal app experiences is something that all of us are dealing with. The second one is social. You're building in all of the social semantics. Things like sharing is not a bolt-on, but it's built into the application. But you go far beyond just sharing by email or sharing links to having things like follow and like, and all of the semantics of social are built into your application. And lastly, you want to make your application intelligent. In fact, if you take even just the social features, once you have opted in and friended somebody in, say, the Bing experience today, the fact that you are now bringing in all the photos associated with your friends and making that part of the results set from a search results perspective is the kind of experiences that we will build even for our corporate applications. That means we're going to reason over large amounts of data and generate recommendations, auto-suggests, and features that make your applications that much more powerful. So this coming together of personal, social, intelligent applications is what all of us think we're really going to have to do as we reinvent the applications for this cloud operating system. Now, not only do you want to build these applications, you want to rethink how you manage the life cycle around this application. So the build, measure, learn loop, how development and operations come together, also requires a fundamental rethink. And some of the innovation in Visual Studio and System Center that we have done in order to enable that new life cycle is, again, going to be very, very important. And so when we think about what our core platform and tools enabled to build these mobile, social, and data-driven applications, we think about it in a couple of different layers. At the foundation, of course, for any application platform is a rich set of runtime services. So the combination of Windows Server and Windows Azure, you have the full spectrum of services from storage, compute, web, media services, a bunch of middle-tier services like the cache, the service bus. Above that, you have a rich set of frameworks. .NET 4.5, amazing set of features to be able to build this new type of modern applications with async pattern to the clients. And then on top of that, you have the new tool set. Visual Studio 2012 is a fantastic tool set to be able to build these web and rich client applications for the world of connected devices and continuous services. And to give you a flavor for how to go about building some of these applications, I wanted to introduce both Scott Guthrie and Jason Zander, but Scott's the first person up on stage to show you some of the capabilities of our application platform across Windows Server and Windows Azure. Scott?
Cool. Thanks. So Satya just talked about some of the great new capabilities that we're going to be shipping this summer. I'm not going to spend a few minutes walking you through how you can build an application with them. And specifically, we're going to build a mobile web application that we're going to host in the cloud using Windows Azure. And we're going to build it using ASP.NET, MVC4, Visual Studio 2012, and Windows Azure. And we're going to get started here inside the new Visual Studio 12 RC that just came out. And we're just going to build, file, new project. And I'm going to pick the new ASP.NET MVC4 application project template. And one of the cool things about ASP.NET MVC4 is it comes with a bunch of new capabilities. And one of the really nice new features is built-in support for building mobile web applications. And so I can just pick the mobile application template. This is going to give me a project that has all the files I need in order to build a web application that works against any type of phone or tablet device. And I'm going to just customize it here for TechEd. We'll just say, hello, TechEd. And I can run it in a standard desktop browser, or the other nice thing about VS 2012 is it allows me to plug in new emulators and new browsers. And I can select them from this list. And I'm just going to launch this here using a third-party emulator to see what this little app looks like. And you can see here it's a very simple app. It just says, hello, TechEd, customize. But it has kind of nice navigation and animation UI that works great with a variety of different phones and tablets. And I got a little Hello World app going here now. So that's building Hello World inside VS 2012. Let's now deploy this on the internet. And specifically, we're going to use Windows Azure. And so I'm going to drop into Windows Azure's admin tool, admin portal. You saw Mark use this a little bit earlier when he was setting up virtual machines. And so he said, sort of, new virtual machine inside the tool. I'm going to create what's called a website, which is a new feature we just shipped with Windows Azure last week. And specifically, we're just going to call this a SkyGoo TechEd. I can choose what data center I want to create it in. I'm just going to go ahead and hit create. And this is going to provision for me a website that I can deploy any web-based application into. One thing you'll notice is how fast it is now inside Windows Azure. So we literally just stood up a new website in one of our data centers. If I click in, I see a similar dashboard view to the one that Mark showed with virtual machines. This one, though, is optimized for websites. Now, I don't have any monitoring data showing up yet because I don't actually have my website deployed. So that's going to be our next step that we're going to use here. Now, there's a couple different approaches I can take to deploying a website inside Windows Azure now. I can use standard FTP tools and just copy bits up. One of the cool features that we also support is integration with source control. So if you have Team Foundation Server running either on-premise or hosted using our online service, you can easily link your TFS account and your projects with Windows Azure, and then anytime someone checks in source code into that project, we can automatically do a build, run your unit tests, and if they succeed, deploy the project automatically into Windows Azure. Really cool feature, and we're pleased to announce, even better, today we're actually taking our TFS Online capability out of preview and opening it up so that any of you can actually sign up for free and try that out. What I'm going to do here, though, is just actually click this fourth link here called Download Publishing Profile. And this is just going to download an XML file that has all of my published settings. And then I'm going to set this up inside Visual Studio so we can just directly deploy within the IDE. And doing that's really easy. All I need to do is right-click Publish. I'm going to pick that publishing file that we just downloaded, and I can just click Publish. And this is going to cause Visual Studio to package up our files, upload them into Windows Azure, into that East US data center, and basically launch a browser with our app. And so I hit refresh here. Oh, hold on a second here. I'm going to hit publish. Uh-oh. And of course, the one time I deployed, it won't work. Let me actually switch now to another machine. There it is. Look, it deployed. So it's running here on this account. And so what you can see here is we have this app running inside Windows Azure. And in fact, if we go back to our portal here, you can see dashboard statistics around this app that was deployed. And one of the things you'll notice here along this line is a number of statistics in terms of number of requests that have hit. So I actually start getting real-time statistics around this deployment, and I can see kind of exactly what's going on here. And now I have kind of basic app up and running and working fine within the system. Now, this is sort of hello world. Let's actually make this a little bit richer. And what I'm going to do here is go to the slides. I want to extend this application to add some additional capabilities to it. And so specifically, we're going to do a couple things. One is I'm going to modify this web app so that I'm going to have a nice little HTML form on the front end. And what I want to do is make this a little social and interactive here and basically build an app so that all of you can send me messages and we're going to display them on the screen. So we have this mobile app that you can use on your phone, so get those ready, that you can go and hit a URL, you can type in a message, and then what we're going to do is modify the app so that every time someone posts a message to this mobile app, we're going to write some server code that's going to take that message, put it in what's called a message object, and stick it in what's called a service bus queue. And the service bus is another cool feature of Windows Azure. It's a really powerful messaging capability that allows me to link code running in the cloud with code running on premise. And then I'm just going to build another app, which is just going to pull that message down and output it to the screen. And so hopefully I can see all of your messages showing up on my local system here. So we'll go back now to the Visual Studio, and let's walk through the code necessary to make that happen. So what we're going to do here is drop back into Visual Studio here. And step one is I'm just going to add a reference to the service bus. I'm just going to use the NuGet package manager in .NET in order to add an assembly there. This gives me all the APIs that I need to program. I'm then going to update the HTML form in our mobile app. Have a nice little form here that lets people post. I'm going to change, get rid of some of the default actions in my controller. and just replace them with a little bit of code that's going to use the service bus APIs we just imported. And specifically, this code here is just every time someone posts a message, I'm just going to create a message object and send it off into the service bus queue. And then last but not least, I'm going to update my web.config file. And put a connection string here, which is just the connection to my application. And now when I run this locally, no, pay no attention to that. When I run this locally, I'll tell you, let's run it remotely and be bold. One of the things you'll notice that we do have support for now inside VS 2012 and inside Windows Azure is what we call incremental deployment. And what this allows me to do is allows me to actually see differences between files local and on the cloud. And so rather than have to redeploy an entire application, when I want to actually supply an update, I can just go ahead and hit redeploy there. When I do that, it will just sort of deploy the incremental changes to the application up to the hosted cloud environment. And now it actually works in the cloud. And so I can now say, hi, Scott. Hit send. This is going to connect to our service bus. It's going to post a message. And now I should have a message waiting for me in a queue. And to read it from the queue, I'm just going to run this application here, which is a command line console app that's going to run on my laptop. And it's just pulling messages from the queue and displaying them onto the screen. So when I run this now, there we go. Oh, someone already found the URL. How wonderful. And so what you can do here is I can, on the left-hand side, I've got an app, targeted mobile devices running in the cloud. I can say, let's say, the guy next to you. We can make it interactive. And the cool thing is, you can all participate in this too. So pull out your phones, go to messagescott.net. You can go ahead and run this app as well. And basically, we've basically connected this system up. We've got an app in the cloud, and anyone can go ahead and try sending a message. We've built it in only a few minutes. We've built it in only a few minutes. You can run it anywhere on any device. And the cool thing is also we're showing connectivity between the public cloud and the private cloud. And there's no end of fun that you can have with this application. And you can scale it out anywhere. So, simple, fun demo. Hopefully shows off some of the power of what you can do with Windows Azure. Cool thing is all the features I showed here, you can do now. So all the bits are available. You can download, sign up for free, and build all these things on your own. We've got a lot of great sessions. I'm going to be doing one a little bit later this morning where you can learn more. So now that we have a large fee of very interesting comments, I'm going to bring on Jason Zander, and he's going to show you how you can build even richer device applications that take advantage of them. So here's Jason.
Thanks, Scott. Good morning, everybody. So we just saw a great example of building some fantastic cloud functionality in the back end. Make sure you keep that website up because we're going to keep using that. The next step we have, once we get the cloud services up and going, is we want to be able to hook it up in all sorts of interesting ways to all these clients that Satya talked about. Now, I've got a couple of devices I want to dig into here. The first one right here, I've got a couple of ARM tablets running Windows 8 with Metro style. And these are really dev kits. The little barcode sticker says CLR. So if the CLR team, if my team's wondering where these two machines are, they're in Florida. So we're going to show these off. Now, what I've got is Visual Studio 2012. This is the release candidate right here. And as you notice, well, we got a lot of great feedback around the beta and some of those sort of things. Some of you gave us some good feedback on the UI. So I appreciate that. One of the things you will see here is that we've added quite a bit of color back into Visual Studio 2012. Popular request. We've done a few things with the UI. So you've got some additional color here. You see you can actually drill down to symbols and those sorts of things. We've added a lot of color on the outside. We've also gone through and made it easier to find docking windows and things like that. And we're still maintaining the focus on the core portion, which is your code, your forms experience, those sorts of things as well. Well, let's go ahead and build this application. So I've got my ARM device over here, and I've got Visual Studio 2012, and I'm in a Metro application, in this case a C# application. And you see I've got exactly the same code that Scott just showed working from the web, but now we're inside of the client code here as well. Now, if I go up to the remote machines, you can see I can attach. If I go back and look, yep, there's my 2 machines. And so as Scott showed, we can actually attach to whichever one we like. I'm going to go ahead and hit remote, and if we show split screen here, we're going to go ahead and do the build. We'll kick off the deploy. You're going to see Visual Studio on the left-hand side, and you're going to see the ARM tablet running on the right-hand side. And we're going to attach with our connectivity. Of course, we're going to keep running Visual Studio itself. No, let's go take a look at that. Okay, let's try this one more time. So on the remote machine, you can see we're actually running the debug monitor. I tell you what, let's cancel that and go to the second machine. That's why we have 2. So we'll go to 1, and we'll switch to that. There we go. So if we can switch the machine on the overhead to 14.8, please. Okay, I don't think this one's going to connect either. All right, I'm going to cancel this one out. What we've got is, with the remote debugging, let me just talk about this for a minute and tell you what will stop this. Yes, we'll go ahead and terminate that. Okay. Now, what I will do is I will back up here, and we'll take a look at the simulator machine that we've got right here. So we'll go ahead and launch this application. Let me set a breakpoint over here and run. Now, the application that we're actually running, again, it's connected up. So we also have the simulator option. The remote option here is to enable us to very easily connect to another device. And the cool thing about this, if we've got our messages coming in across this, we can do a nice Metro interface. So we've got all the tiles that are set up to connect and pull back different information. For each one of those, we can go back and pull individual items back by country code and those sort of things. When I hit my breakpoint, of course, you're going to land inside of the normal breakpoint and call stacks, all the rest of that stuff. In this case, we're in C#, and we're running against the simulator. The simulator gives me all the debugging capabilities that I have. It's actually running on the same machine, and so I can get all that content. If I hit F5 and go over here, the simulator is also going to give us additional settings. So you probably don't have every single type or config of machine. In fact, these screens are much, much smaller, and so with those, I might be able to reset the focus. I can make it really large and look at the layout and those sort of things as well. Now, the nice thing about all of these is that once I get going, I can actually use the same debugging techniques for all of them. So even if I'm on ARM, it's a different chipset, but it doesn't really matter because my breakpoints, my call stacks, watch windows, everything else is going to work exactly the same. If you're using C#, for example, same thing for JavaScript as well as C++. So we've got some additional information coming out about all of that kind of targeting that we have. So go ahead and take a look at that and give that a try. Now, the next thing I want to be able to do is let's talk about other types of clients. So that was an example of building a Metro-style application. We also want to be able to hook up other types of applications. Many of us here are probably building line of business applications, things that have lots of data, lots of screens. I might be using these as internal apps and those sort of things. Let me show you an example of that with Visual Studio LightSwitch. This application that we have here, LightSwitch, is a development environment that we've created to make it really simple to create the type of application that you see here. You can basically just add data, you can add screens, and with the previous release, we could also include things like SharePoint. With Visual Studio 2012, LightSwitch is built in, and we've added support for OData as well. Now, OData is becoming a very, very popular feed. It's an easy way to get a hold of data from all sorts of vendors. We actually have it submitted in for standards. One of the things I want to show you here is we'll go ahead and do a search on customers. And if I pull up, let's look at Chloe's, for example. And this application that we have, we're a moving company. So we keep track of our employees. We keep track of all of our appointments, those sorts of things. If I go ahead and look at this particular customer, one of the things you'll see here is I have my appointments, but I'm also using the SAP NetWeaver Gateway, which exposes OData. And so with this, I can actually very easily attach to my SAP system and pull both of those in and kind of mash it up in one system running right here on top of my desktop. So lots of cool support in there, and that's neat. This is content you can get now with Visual Studio 2012 with the RC. Now, we have some additional support that's coming. I want to give you a preview of that. Now, in this case, I'll go ahead and pull up the application itself. That's a nice application that works pretty well. Now, the problem that we've got with my Move It company is that we've got a lot of independent contractors that we also work with. You know, the folks that actually go out and drive the trucks and actually help customers. We want to make sure that they have access to our internal systems too, because we can give them their job lists and all the rest of this kind of stuff. Now, the problem is, I don't control their IT. I don't know what kind of systems they're running. They may just have a smartphone. I don't even know which type. So I'd like to be able to expose this data as well. But we need a way to go do that. So I'm happy to announce here at TechEd for the very first time, we've not told anybody this, we've added HTML support for LightSwitch. Now, I can go ahead and add HTML off of the front end on here. Now, we've actually done this already. So if I expand this client over here, let me go ahead and set the mobile target as the startup client. And I'm going to go ahead and do a debug. Now, that'll go ahead and build the application and go ahead and run it. Now, in this particular case, again, we haven't done any changes to the back-end system. So we're still working with the same database and the SAP system, all the OData feeds and that kind of stuff coming through. But I want to write this companion application that's going to run on all sorts of devices. So we're actually using HTML5. So we're using jQuery, jQuery Mobile, HTML5, JavaScript, CSS, all the same sorts of stuff that you would use to build a normal website. So I can even look over here and see the DOM Explorer. So this is a good display of customer information. But as you can see, it's kind of a big, broad band over here. So one of the things we might want to do is kind of change the formatting. Now, again, one of the goals for working with LightSwitch itself is to make it really fast and easy. So I'm going to go ahead and double-click on the home project at the home page, select the list that we're displaying, and I don't have to write code if I don't want. In fact, I haven't really written any yet, but if I do want to add any code, I can just go in, write code, and go add some formatting elements. This takes us into our JavaScript editing environment. And again, we're just using jQuery. So this is standard jQuery syntax. Find the element, look for the unordered list, and go add the selector for tile list. I'll go ahead and hit F5 on that. That's going to go ahead and compile the application up again and go run it. Once again, we're projecting back out jQuery Mobile with the content, but this time with a new selection in there to go change the formatting. And in this case, that formatting is designed so we get a little better flow. In fact, if I were to pull my browser over a little bit, you'd actually see that maybe this is like more the size of a phone. So I get that nice kind of flow for all sorts of forms and tablets. Now, that's pretty easy to do. I didn't have to go write a bunch of code or anything like that. Now, I also know that some of you may be carrying around other devices that have weird pictures on them. You probably want to have access for that too. So let's switch over to one last example here. And I can hit that same application. I'm running the iPad emulator. And if I go ahead and hit the same website that we were just showing, I can go ahead and load that. And so if the person does have that kind of device, then that same app that we just did the formatting and all the rest of it on, and here it is on this device as well. All right, so very simple, very easy to get going. Just want to go ahead and switch over to the slides here. So that's a couple of different ways to build great applications. I can build very rich clients. I can also do standards-based. Scott showed you how to do that with websites in the back end. We have LightSwitch for easy HTML generation. So you've got that kind of standards that Satya had talked about. Now, the next thing we need to be able to do, though, is it's necessary but not sufficient to go build great software. All of us in this room, IT professionals as well as developers, we got to work very, very close together if we want our customers to be happy. Like, I got to build the software, and I got to deploy the software and keep the thing up and running. So we've got a lot of fantastic tools already with Visual Studio. In fact, just last week, Gartner released their ALM Magic Quadrant, Application Lifecycle Management, and you'll find that Visual Studio is in the top of quadrant now with that report. So we're very excited about that. And that's even for Visual Studio 2010. We have even more coming. So we've got a lot of great support for agile development, being able to do tests and the production, all those sorts of things. That helps us out on the left-hand side. But again, all of us in this room have to be working together if we're going to be successful. So we also need to get integration. And when we get issues, and they're going to happen, how do we get that mean time to resolution to be, as fast as possible? I want brand new features coming in, and when I have issues, let's go resolve things quickly. So let's go look at some new examples of how we can do that. And I'm going to start off, first of all, as a developer. And I have a website here that we're a B2C sort of site, and we sell toys and those sorts of things off of this particular site. Now, we'd like to go worldwide and have a global presence. And so, okay, this is a pretty straightforward app for me to go build. Now, what I do want to do, when I'm building the application, I've got things like web tests that you see here. The web test allows me to go through and automate functional testing. In this case, we're testing the checkout cart. So I want to make sure that when I add items that go through in the checkout is successful. So that makes sense. I'm going to run functional tests in order to validate things. Okay, that's great. Now, once I'm done with that, I want to hand it off to ops, and I want us to be able to deploy it, get customers on board. So let me put on my operations hat for a moment. We'll go over here to my favorite tool, which is System Center. Now, I'm happy to announce today that we want to show you some new functionalities coming out with System Center 2012 SP1 Global Service Monitoring, or GSM. And GSM is going to give us the opportunity to do monitoring worldwide using Azure and all the points of presence that we have around the world in order to be able to make sure that your machines are up and running. Now, if I go ahead and click Add on this wizard right here, you can see right here I have that same test. So the cool thing to notice is I'm using an asset as a developer to do the functional testing, and I can share that with my operations partner on my team and say, let's go ahead and use that to go do the monitoring. When I add this guy in, then I'm able to go through and say, well, where would you like to run it? If I go do a search, I can run all sorts of points using Azure, again, around the world. Go ahead and add these in. Okay, that all looks good. Now, with this, I'm able to very quickly configure, share an asset with my dev team, but now I'm going to do monitoring. For the sake of time, I'm just going to cancel out of this one because we don't need to get it going. We've already run it. And we'll shut down that application. Now, I'm going to start getting a couple of views now as I monitor the app. One, I've got a worldwide view and a map showing me how are things going. Looks like it's mostly okay, but we do have an issue in London. I'm also going to get response times and timings and see how well is the application going. Now, we do, again, have this problem with London, which seems like an issue. So at this point, of course, I would go through my normal set of things to look at, the network and the machines and the configurations. If I do decide that this thing is just not really ready, I really need to assign it to engineering. So I'm just going to right-click and go ahead and do the assign. Now, the cool thing about that is we're letting the software now do the work for us. We're running the tests that came from engineering. We actually collected a whole bunch of diagnostics information that we want to get over to the engineering team. So, again, if I head back over and put on my engineering hat, one of the things I'm going to see is that in TFS, that issue has been routed to me. So I'm getting in TFS the bug report, and it's saying, hey, you're getting a SQL exception. If I look through the attachments, I can see I'm getting an IntelliTrace log that was captured for me from ops. Nothing special they had to do, but it gets routed. I can look through the exception data, and clearly I am getting some SQL exceptions. If I go ahead and do a start debugging, that'll debug the log. So it's not a live attach, it's debugging the log locally. So as a developer, I can see that. And I get local variables and those sorts of things. Now, I can see that in this code, it's pretty clear what's happening. I'm doing a lookup on the UK country code, and it's not finding it. So that's clearly an issue I have to deal with. At this point, I know how to resolve it. I can go fix my data or the service that's surfacing that information. And when I resolve it, it will go back into TFS, and it'll be reflected. So with this, the cool thing is everybody in this room is probably using Visual Studio for devs, System Center for ops. We're going to be able to start cooperating very closely with each other, and we're going to be able to start releasing features much, much faster. So that's the vision around developer and operations, and we're adding a whole bunch of support for that going forward. Now, with that, what I'd like to do is show off a case study that we've got from ING Direct, and they had very similar sort of problems trying to figure out, hey, how do we get this, this time, the amount of people we take, the amount of time it takes to develop software, and using private clouds, Windows Server 2012, System Center, Visual Studio, and everything put together, they're able to get some pretty dramatic reductions in part of this production pipeline. And I think the excitement about that solution shows through pretty well in the video. So with that, we'll go ahead and roll the video, and I'll say thank you very much.
ING Direct Australia had 49 developers, 18 testers, and a project backlog of 18 months. Developers couldn't wait that long for test environments. They needed to deliver innovation faster. They needed a copy of the bank at any time at the lowest possible cost. They needed a bank in a box. The bank-in-a-box solution was developed collaboratively. It's fully integrated with a dev test tool suite, including Microsoft Visual Studio, allowing devs to provision environments easily. It's a platform with agility built into its DNA, that will help ING Direct get cloud ready. Now they have a DevOps solution, the dev test provisioning environment that no longer takes months, it takes minutes. That's a competitive edge.
All right, so that was a great set of demos that showed you development of new apps across devices, how DevOps and a new lifecycle come together. Someday I'll even convince Guthrie that Service Bus is for durable app-to-app messaging, not an instant messaging system for him. But that's another day. But we have a very, very rich set of runtimes and tools and frameworks to build applications. But it's not really the end of the story when it comes to modern apps. One of the other most important considerations for us is how do we rethink even access and device management? Because if you build these applications, take, for example, one of these SAP-connected business applications that you build using LightSwitch. You want to make it available across all devices, but you can't attest to the health of all the devices, so you want to set policy based on the type of application, based on the user and the device, give restrictive access. You may want to encrypt data. So there is a real rethink in terms of enterprise access and device management. And the fundamental thing you want to make it is much more people-centric. It's not about a particular device, but it's about the particular person and the device that they're using and the applications they want access to. You want to make available all of the applications and all of the data to that user on that device, but at the same time, from an IT perspective, have the control and governance framework. And so to that end, we are really extending System Center with Windows Intune. You should think of Windows Intune and System Center providing that combination of control and governance so that you can give the right access to the user on their device for their applications and data. First thing that we have done with this new release of Windows Intune is integrate with Azure and AD. So for example, if you're an Office 365 end user today, you log in with the same single sign-on into Windows Intune. Then you can go into a self-service portal, look at all of the applications. Your IT administrator would have then given you access depending on the type of device you're using, because there's an inventory of the device, the ability to integrate the device to find out whether you can attest to its health. And based on that, you may get a VDI session, a rich application. You may encrypt the data before sending it down. All of those mechanisms are things that you can set policy on. So Windows Intune will do this across all of the devices, Windows Phone, Windows 8, which you'll hear a lot more about tomorrow, as well as the other devices from iPhone to Android. So we have a multi-device management, great people centricity with Azure AD integration, and self-service application pull, if you will, to complement everything that you're already doing with System Center. The last dimension of a modern application is data. At some level, a lot of the applications that Scott and Jason showed already had the power of data. But for us, thinking about data as a first-class part of our application platform is pretty important. With SQL and SQL Server and SQL Azure, that's one of the places where we're investing very, very heavily. We want to have a complete storage portfolio for any type of data, for the NoSQL pattern to the SQL pattern, for OLTP to BI to data warehousing. We want to, at the core level, have a complete data platform. Second, we want to have rich capabilities to reason over data. Basically, how can you add intelligence to your application by doing things like applied machine learning? How can we connect up all of the enterprise data and look at that together in terms of data mining? Connect it to data that's there in Bing in order to be able to reason over the world's knowledge as a union of your data and the world's knowledge. And lastly, how do we connect these petabytes of data in many cases to real insight by having Excel connect with big data? To give you a demonstration of that last theme, where more data doesn't necessarily mean insight if you don't connect petabytes to end users, I wanted to invite up on stage Amer Netz from our SQL team to show you what we're doing in some of the new capabilities in SQL. Amer?
Thank you, Satya.
Thank you.
Hi there. So the modern business applications generate massive amounts of data, big data. And we talk a lot about building these large Hadoop clusters to store all of it. But just as important as storing the data is making sure that users can make sense out of all the data, make some real business decisions. To show you how this is done, we have used our own Hadoop cluster to collect a bunch of tweets, 12 million tweets about movies. And we have this now large pile of unstructured data. You know, it's a 12 million, 140 character strings, and let's see what you can learn out of it. And to do that, we're going to use Power View of SQL Server 2012. So we see here SQL Server 2012 on the screen, and we have here the 12 million tweets. And one thing that we can do with Power View is modify the data and follow our hunches. So instead of just looking at the total, I'm going to change it to take a look here. It is a column chart, and we're going to see how it behaves over time. So just like that, we can see here tweets over the last 5 months, and we can see some really interesting patterns that are emerging. There's a nice spike here of tweets that is occurring on March 23rd. There's a big pile of tweets here at the beginning of May. So something is going on, and I, as a business user, might be interested in following some hunches and figuring out what's going on. Maybe it has something to do with movie releases. So I can go in here and try it out. I'm going to take the tweet counts. I'm going to look at the movie title. I'm going to make it into a bar chart, make it a bit larger, and we're going to sort it. And we can see here the various tweets for the various movies. We can see the most, the movie that had the most tweets was The Hunger Games. Maybe it can explain some of the spikes we're seeing here. I'm clicking on the bar of The Hunger Games, and immediately I can see that The Hunger Games is truly responsible for that peak that we had there at the end of March. In fact, The Hunger Games was released on that date, on March 23rd. The Avengers, well, that one is responsible for the spike that we're seeing at the beginning of May. You can also see here in the Hunger Games the anticipation that the users had here for the movie because of the book. So all that is great insight we're getting here from just looking at the tweets. But what kind of business decision we can make? Well, put yourself for a moment into the shoes of a theater operator. Maybe the most critical operational decision that you have to make every week is how many screens to allocate to each one of the movies. Well, maybe the tweets can help us make that decision. So we're going to go and do some experiment here. I'm going to go and maximize this chart. I'm going to focus only on the top grossing movies for my analysis. And I'm going to look only at the tweets that were tweeted before the movie was released. That's our leading indicator. So I'm going to go in here, change to say only tweets that were before the movie was released. So a different number of tweets. And now let's compare and see if it's correlated well to the revenue of the movie. So we're going to go here, take a look at the revenue in the first week. And the side of the bubbles is the revenue, overall revenue. And now we can see that, on the x-axis we have the tweet count, on the y-axis we have the revenue, and we can see that there's a very strong correlation. The more tweets the movie is getting before the movie is released, the better it will do in the first week. Of course, there's one exception here, right? The Avengers is getting way more revenue than the tweet would let you believe. And I actually tried to figure out why is there an outlier here. I went to see the movie, and I still cannot figure out why it did so well. So this is kind of the first decision a theater operator has to make. The second decision comes a week later. Now we're getting to the second week, and in the second week, generally, the movies are doing less, generating less revenue than in the first week. And you can see it here, right? The blue bar is the revenue in the first week, the red bar is the revenue in the second week, and it's always going down. And we can actually see that the drop between the first week and the second week is not consistent. It's actually different movies. Oops, I'm actually doing the wrong one. There you go. And we are here. The drop between the first week and the second week is inconsistent. Some movies are dropping much faster than the other movies. And the question is, what is leading to that drop? And you can see that it's not really the number of tweets that can give us the clue. What can really give us the clue here is the sentiment analysis. And what we've done on our Hadoop cluster, we already calculated the sentiment of the tweets, whether people are saying good things or bad things about the movie. And when you look at the correlation between the sentiment and the drop between the first week and the second week, you can see a very clear correlation. The higher the sentiment, the lesser the drop. So if you look here at the movie that had the worst sentiment, we click on it, you can see this was John Carter. John Carter, was a mega flop. All the revenue was done in the first week. People went to the theater, saw it, told their friends, tweeted about it, and nobody came the second week. Now, on the other hand, we look at the movie that had the best performance in terms of sentiment, and this is the movie. It's A Dictator. It has a phenomenal sentiment, and in fact, it was so good that it did better in the second week than in the first week. People went to the theater and then tweeted and said, that was actually much better than the reviews would let you to believe. Word of mouth get out, and people going to the theater even in droves, even more than in the first week. That's a really rare phenomenon. If I'm a theater operator, I'm not listening to the sentiment on Twitter. I'm missing the opportunity to allocate more screens to make more money. So that's critical business decision can be driven here by the sentiment. Now, the other thing you can use here with Twitter is manage brands. And in the movie industry, one of the biggest brands is actor names. So let's take a look here. I'm going to move here to the next screen, and we see here a list of actors. And this list here is not just any list. If you look at the list, you might recognize some of the names. There's something special about this group. All these actors here were nominated for Academy Awards, either a leading role or supporting role. So this is a fairly distinguished set of actors, and each one of them is a brand name. Their name is worth money. They use it in commercial, use it in so many other occurrences. So it's worth money, and awareness of brand is very important. So we can associate the tweets to the actors and see who has the most awareness on Twitter. And you can see here very clearly that Brad Pitt and George Clooney and Meryl Streep, these are our A-list actors. They have way more awareness than any of the other actors. But that's kind of important. It also could be interesting for us to go and take a look and see how the tweets are behaving over time. So let's just go here. Let's go copy, paste. And we're going to go and change it a little bit. So let's go and tweet by actor. Instead of looking at by actor, we're going to go and do it by date. And we're going to go and change it into a line chart. And we can see that the pattern of tweeting about actors has a really spiking behavior. You can see a very large spike here on January 24th. So something very special happened to this group of actors on January 24th. This is a date where the nominations for the Academy Awards was announced, and the whole internet is blazing with those names, and Twitter is full with tweets that mention those names. But the behavior for those actors is different. Let's look here at Brad Pitt, highlighting Brad Pitt, and you can see that for Brad Pitt, January 24th was just another day in the office. Nothing special. He doesn't need that nomination for the Academy Award. But for other actors like Melissa McCarthy here, well, January 24th was really important. You see, nobody remembered Melissa McCarthy at all, and then January 24th comes, giant amount of tweets mentioning her name, and then everybody forgets about her. Now, we can go and take all these things and combine them together and see how they really operate. So I'm going to go here and let me change the style here to add here some the layout here to add some data labels. Maybe put them above, to the center. So what you see here, the various male actors that we have here, and we have here on the x-axis, we have the percent of tweets to date, and the y-axis, we see the sentiment. And let's see how this nomination affected each one of them. So we'll start with Max von Sydow. Max von Sydow was one of the elders of the movie industry. He started his first movies with 1946. He's 83 years old today, and he was nominated for a supporting role in a movie called Incredibly Loud and Extremely Close, or something like that. And you can see that before the nominations, Max von Sydow had very little tweets. Almost nobody was talking about it. Almost nobody had any significant sentiment about him. But we're going to highlight Max here, and we're going to see what happened. So we're going to get to January 24th, and suddenly you see a giant spike in awareness about Max von Sydow. And the sentiment is going up. People say, wow, he must be a great actor because he's nominated for the Academy Award. And then it tapers off, but overall, Max von Sydow ends up in a much better place than he started with. And that kind of makes sense, right? And you think that it's always happening this way, but it actually doesn't always happen this way. So let's take a look at another actor. We're going to look at Demian Bashir. Now, Demian Bashir was nominated for a leading role in A Better Place. And actually a better life. And we're going to go and see that he actually had good sentiment, little awareness, and January 24 comes, and a giant spike in awareness, but actually sentiment is going down. People, for some reason, not liking the fact that he's nominated, and in fact, it's going down, down, down. He's ending up in a very, very bad place. If you're a PR manager, you're managing the brand of Demian Bashir, you have some work cut out for you to figure out what's going on. Some business decisions have to be made, how to make sure that the public perception of Demian is much better. And of course, we have our last hero here. We have here Brad Pitt. Brad Pitt is a brand name household. For him, January 24 comes and goes. He just have giant volume, same sentiment. People already made up their mind about Brad. Brad doesn't have to worry about anything. He just focus on the wedding and have fun, right? So you've seen here what we've done, right? We took 12 million tweets, 140 characters each. From this pile of unstructured data, we're able to figure out how to predict the first week sales, the second week sale. We were able to manage a brand with awareness, with sentiment, with impact of events on those. And we did it in a way that was fun and easy that anyone can do. Isn't it just amazing? So, yeah, just imagine what you can do when you give this tool to your users. Thank you.
Thanks, Amir. So that was a whirlwind tour of all of the capabilities that make up the cloud operating system. If you look at what we talked about the next generation of data center infrastructure. We talked about the next generation of data center management, application runtimes, device management. All of these capabilities across the modern data center and the modern applications is what we've been hard at work building over the last year. You see that in the wave of products that are launching. And that cloud operating system is the core capability that we wanted to make sure we can first do a great job of building it out comprehensively and consistently so that we can equip you with it so that you can usher in the era of the cloud operating system within your own organization and reinvent the value together to drive additional business value for your businesses. Thank you very much and have a great rest of the conference. Thank you.